design arguments. So the problem is with intelligent design that it has polluted the whole area of talking about design, because anything design is then intelligent design, and that's not necessarily the case.
Yeah, see, I'm even polluted. Well, anyway, thank you. Hopefully, let's get some, like maybe you'll filter this air.
Well, thank you all for coming. I was actually kind of worried that because of the snow that would be a little bit of an empty room, but actually I'm quite pleased that the turnout is so great. Okay, so the laws of nature basically, so we're talking here about physics. So it's how the universe is built, and so not just how physics works in like planet Earth and the sun and everything, but the universe as a whole as well. I first want to give a few examples. And does anybody have a pointer or something? That's okay. So one is simple, the physics of atoms. And so we have here the nuclear efficiency, which is epsilon is 0.007. That basically it describes how much of the energy of a hydrogen atom is converted. How much of So when hydrogen atoms are fused to helium atoms, some of the mass is converted into energy, and that fact talks about that and is dependent on a strong nuclear force. So then fine-tuning means basically that it's very critical how the value is, because any slight deviation from it just would make physics and life impossible to exist. So here, when it would be just a little bit weaker, then a proton could not be bonded to a neutron. We would not have deuterium, which is basically a hydrogen atom with an extra neutron in the nucleus. And then the route to helium and all the heavier elements would be prohibited. So basically, we would have a universe that would only consist of hydrogen atoms, and not much exciting would be going on. No chemistry, nothing. If it would be a little stronger, then two protons could bind directly together, and then no hydrogen would be available as fuel for stars. No star burning. No energy sources, no evolution of anything whatsoever, physical evolution, biological evolution. Then related to this is carbon production that is also dependent on a strong nuclear force. So this is a very interesting process. There's a three-way collision of 3 helium nuclei to produce 1 carbon atom or 1 carbon nucleus. So a two-way collision, that's easy. But how do you get 3 particles together colliding just at the same time? The chances for that happening are extremely small. It's crazy. So what they then found is basically that there's a resonance that arises when the nuclei collide, and so that resonance basically makes the chances that all those 3 particles fuse much more. It makes it much more likely. So so that is necessary for carbon production. So again, very sensitive to this thing. So if that nuclear efficiency would be just a little different, we would not exist. Then then let's take an example, the second example, cosmological constant. So that is not just the physics, the everyday physics, but that actually is something that describes the entire universe. It's the expansion of the universe. And so let's say that we have a value which is not too big, 1, okay? And then we would have a value of -1. It's a negative cosmological constant. Then the universe would last an incredibly infinite amount of time. If it would be this value, which is very, very small, it would only last this amount of time. So basically, a blink of an eye would not describe the existence of the universe. On the other hand, if we have a positive constant, +1, here the universe doubles in size every minuscule fraction of a second. It's like crazy. If we have a value of 10 to the power of -48, that's an incredibly small number, okay? The universe would still double in size. It takes an electron in an atom to orbit the atomic nucleus once. The whole universe would double in that time. So everything would be ripped apart. Atoms could not even exist because it's just crazy, the expansion. At an even smaller value, plus 10 to the power of -80, it's an even more incredibly small number. The universe would still double in size every 1,000th of a second. So your body would be ripped apart right away. So the actual cosmological constant is 10 to the power of -120. If you would write this in decimals, this is what you get. So physicists are stunned by, it's very hard to explain this in a natural fashion because with the normal calculations from physics, if you would take relativity and nuclear physics, then you would, if you would take that together, then you would just end up with cosmological constants that are way too big for anything meaningful to exist. So these were just 2 examples. Now comes a list of everything that needs to be right. So we have an extremely low entropy of the Big Bang. Low entropy means very high order. So it's supposed to be an explosion, but that explosion happened in an extremely organized manner. So you can't just, it's not just a bunch of dynamite that you just have poof. It's very, very controlled. Inflation to solve the critical density problem, which is basically the mass energy of the universe needs to be exactly matched to the expansion rate. Otherwise, it just doesn't work. The universe cannot last long enough, certainly not almost 15 billion years. The ratio of electrical force to gravity. Gravity must be very, very tiny compared to the electrical force. So the ratio is 10 to the power of 36, which is, again, like the cosmological constant. We are talking about factors that are way high or way low. And so otherwise, stars could simply, for stars to burn, there needs to be a lot of matter piling on top of each other before the gravitational pressure gets big enough so that it ignites. If the gravitational force would be just a little smaller, then there would not be enough necessary for the material to ignite. Stars would be very small, and so they would not last long. They would not burn for billions of years like our sun, which burns for 10 billion years. There's no time for biological evolution, and we would not exist. The relative masses of the electron, proton, and neutron, very critical. the electron must be very light. The mass difference between the proton and neutron must be minuscule, which it is. It's about the mass difference is 1 to a 2,000th between the electron and the neutron. And this is necessary to get stable nuclei. No stable nuclei, no nothing. No physical evolution, no chemistry, no us, no life. Ratio of dark matter to normal matter. Then we have the Ripple constant Q, which is basically it tells you about the lumpiness of the universe. So when the universe expands, it can be in an extremely smooth way, which is the Ripple constant is 10 to the power of -5. So there's only one unevenness in one part in one part in 100,000. If it would be a little bigger, then things the sizes of galaxies would aggregate into black holes. No meaningful structures could exist. If it would be just a little smoother, then everything would be just a sea of nuclei. Nothing would aggregate. There would be no gravity to pull anything together. We would be in an extremely boring sea of particles. No life. We would not exist. The cosmological constant. I talked about the dimensionality of space, 3 dimensions. In 2 dimensions, we cannot exist because take for example, circuitry, neuronal circuitry. Put it on a sheet of paper, all the lines cross each other. Forget it. 4 dimensions, planetary orbits are not stable. So why 3 dimensions? Why not anything else? Existence of quantum mechanics and the Pauli exclusion principle prevents atoms from collapse. And we need the right chemistry. Carbon, which I talked about, or an equivalent in alien chemistry. So there are so many factors that have to be so critically tuned that you would think, okay, how do you explain this in a naturalistic fashion? Can you do that? Wouldn't you need a designer? So atheists are always very, they love to say, okay, everything can happen by itself. Evolution is a self-sufficient process that works all by itself. Who needs any designer or whatever? However, if you have fine-tuning of the laws of nature, the fact that evolution can occur at all is extremely amazing. Why? Why? If the laws would be just a little different, just a tiny different, no evolution, no physical evolution, no biological evolution, no nothing. So then the question is, the self-sufficient evolutionary explanation collapses with the apparent fine. I'm talking about the apparent fine-tuning because fine-tuning is basically already a philosophical argument. Fine-tuning says there is somebody who fine-tuned. Apparent fine-tuning is a neutral concept that basically says, okay, it looks as if it's fine-tuned. I'm stopping here. That's basically the scientific stance. So, or does it not collapse? So, are there naturalistic explanations for that? First, 2 common objections that you always hear from skeptical people. How can you say that the universe is fine-tuned for life? Like 99.999 whatever % of the universe is inhospitable to life. You have huge star aggregates, galaxies that are empty space, and neutron stars and pulsars and radiation and deadly whatever. Nothing can live. Well, it's obvious that the fine-tuning argument looks at the universe as a whole. It's irrelevant if only a tiny part of it is hospitable to life, that their life can exist at all. That's the point. It's kind of a silly argument. yeah, of course you cannot live on a star. But so who cares? You need energy sources that make evolution possible and that burn long enough. So let's say, okay, I take that, those light bulbs are probably, those neon, this is probably pretty friendly, but take a normal household light bulb, okay? Put your hand around it, your hand will burn, I mean, your hand is gone. But is it hostile to life? No, light is great. It extends what you can do in the evening hours. It's very friendly to life. But of course you don't touch it. So the argument basically is irrelevant. The other one is we are adapted to the universe by evolution, not the universe is adapted to us. So yeah, if we would have other constants, yeah, of course some evolution would take place. Life would simply adapt. But that is obviously nonsense after what I explained, because you have no chemistry, you have only hydrogen and nothing else. No chemistry. You have no stable nuclei. You don't even have atoms. You have a cosmological constant that completely rips everything apart if it's just a little bit bigger. How can you talk even about the possibility of evolution? That argument makes no sense if you look at it a little bit closer. So now, proposals how to explain that apparent fine-tuning without design. First is it's just chance. Well, okay, so what? We are here, so there is nothing to be surprised about. That's easy. Yeah, we are here, so who needs an explanation? However, if you would have so many parameters aligned by chance, that would basically amount to winning the lottery at least twice. This is a very conservative amount. There are people who say, okay, it would be like winning the lottery. One single person would win the lottery, the jackpot, 10 times over. I am conservative. Okay, let's say it's only twice. But even then, if there would be one person who wins the jackpot twice, you would think, okay, of course it's rigged. You don't believe it. That's not chance. Well, however, you could also say, okay, fine. Why should life be important in the grand scheme of things? So let's say, okay, why would we be so chauvinistic and think we are important? Our life is important. Well, let's say there's some random sorting out of parameters at the Big Bang and something else would exist. Maybe not even chemistry, nothing, just some sea of particles. Well, who says that that's not aesthetically pleasing? Because we would not be here as observers to observe it anyway. Why would that sea of particles not be as important as what we, in our little mind, in our little chauvinistic attitude, perceive as important? Why would that not be just as important? Life is just chance, so it's just, so what? But the problem is, of course, you can say, okay, you can have the argument, okay, life was intended by someone. And then you would say, okay, life was designed. So that would be the theistic stance. And then, so life is natural because life was intended. So just brute chance would be an incredibly unnatural thing. So it's rationally unconvincing if you take one very natural explanation against some chance explanation. So that argument is not convincing, and cosmologists realize that, and so they look for other natural explanations. So the next explanation would be trying to make it natural. So the laws of nature are simple and necessary. It's a necessary outcome of, let's say, the combination of general relativity and quantum mechanics. All the physical constants that we wonder about and we are so amazed that everything is so fine-tuned, it's a very simple, it has to be that way. It's just the outcome of what a unified system of that would give, and it can't be any other way. So there's nothing to be surprised about either. However, the synthesis of general relativity and quantum mechanics, which people think might be unified in a system of quantum gravity, that is just one of very many possibly mathematical self-consistent systems. Why should that system, even if that system would explain all the physical constants, which cosmologists these days are not convinced about anymore. So they think even if we have a unified system, the constants would still be free to change. But even if they were all fixed, why not any other system? There could be many other systems out there. You can think of anything. So why would that be? However, then you could say, okay, only the fabric of nothing allows only certain systems to arise. So we must have either what we have or something similar or whatever, but the choices are very few. But then the fabric of nothing is obviously, if you think about it philosophically, is something that makes no sense. Nothing is no fabric because nothing has no properties. The very definition of nothing is it does not have any properties. It does not exist as such. So how can, if something comes out of nothing, how can nothing determine what that something would be? That makes no philosophical sense. Hold on. There will, if you read that literature a little bit, you will see that there's a lot of people who talk about the physical nothing of empty space. Okay, that's the quantum vacuum, and that has very defined properties, and that nothing would not allow maybe for other laws to arise. However, this scientific, that physical nothing is not the philosophical nothing of really being nothing. So don't confuse nothing with nothing. One thing is science. The other thing is philosophy. There's certain philosophical concepts that cannot be explained by. Of course, there will always be those people who say, "Yeah, science is so good. It has explained so much, and let's wait another 1,000 years, and it will have explained everything." However, there are always philosophical questions that science cannot explain. I'm a scientist myself. I would be proud if science could explain everything. However, if you don't concede that there are some limits to what science can do, then it's both bad science and bad philosophy, that attitude. So, for example, the question, why is there something rather than nothing? That is not a scientific question. That's a philosophical question. Science is busy with explaining how things work, how the laws of nature work. Then people will say, yeah, but science has explained so much. Why questions? For example, why does it rain? But that's not a real why question. That's a question of how. Now we know that it's just how do the laws of nature work? How does physics work? How does the weather work? However, the real why questions are simply outside the domain of science. So that the necessity of the laws of nature just doesn't work, because even if our physics system would fix everything, there could be other systems around. This cannot logically be disputed. Third, ha! What about life as we do not know it? Why would we think that only our way of life, well, our life is the only possible? There could be completely alien life with other physical constants, and it would be just, then we would also have life. However, life requires chemistry. So we don't have chemistry if the nuclear forces are different. No, nothing bigger than hydrogen can form. If we have no stable nuclei, if we have a cosmological constant that rips everything apart, how can you talk about the possibility of life? Let's say, okay, we have an completely alien chemistry, completely different particles, and it's completely different. Fine, good. However, you would still think, okay, you need chemistry, because, well, I mean, think about how living things are. You cannot have material complexity without chemistry. So let's say there's chemistry. Completely different particles, completely different forces. So fine. What are the chances that that exists? If you would think, okay, we know from our system if we would have a slight detuning, then our chemistry does not exist. By rational extrapolation, we would think, okay, in that system, also a slight detuning would make it impossible. So then we would say, okay, we have one little tiny spot of chemistry here, and all other possible spaces are completely void and empty and boring. And we have one little tiny spot of chemistry over there, and another over there. So, but the point is not that we are the only universe where life can exist. The point is that the chance that we would exist is just astronomically low. If there are other small islands somewhere of life, it would still, that probability would still be very low. So that doesn't solve anything. Could be life based on things other than chemistry. People were talking about science fiction, life on neutron stars, or like nuclear molecules or plasma or whatever. But this is things that basically cannot be seriously discussed anymore because we don't have any experience with it. And how could they aggregate to higher complexes that would make intelligent life possible? So the last one here is the multiverse. So that's what some people say, okay, the scientific alternative to design. The multiverse is basically, we have our one universe. Now imagine that universe, as big as it is, okay, is just one little tiny point in the spectrum of everything there is. There are trillions and trillions and trillions of other universes out there, okay? They all have slight variations of physical constants. So when you have so many universes, then our universe would have to arise. It would have to be a statistical necessity because there are so many variations, and our variation would be there. And that's born from the ideas of inflation and string theory. So, but then the question is, first, is the multiverse science? So we have the problem of the particle horizon. The particle horizon is the maximum distance from which particles could have traveled to the observer in the age of the universe. So this limits what we can observe. So it represents the portion of the universe which we could have conceivably observed at the present day. But any other universe would be outside this particle horizon. Science lives from observation and experiment. if you can't observe, there's no science. So you cannot call it science if you can't see it, you can't measure it, you can't observe it. It's just an idea. So if it's outside of observation and experiment, it becomes a hypothesis from science, and then it would be philosophy. Nothing against philosophy, obviously. I love philosophy, as you might have noticed already. But it is not science, okay? So if people say, oh, this is the scientific alternative, or this is the argument from science, this is not science. Does it solve the design problem? Well, the problem is if you would have so many different variations to make our universe a statistically inevitable outcome, and the possibilities are so high, then you would have to have this variation in very fine grades and in a truly random distribution. Truly random, very fine grades, because otherwise, if it's not random, then you would have to ask yourself again, who made the choices? So then the argument is this could only be achieved by careful design of the underlying many universe generator. So basically, like the cosmologist Paul Davies says, the problem of the laws of it, the problem has simply been shifted up a level from the laws of our universe to the meta laws of the multiverse. So it really doesn't solve the overall design problem. It solves the design problem of our particular universe, but it does not solve the overall design problem. So the conclusion is we had brute chance, necessity of the laws of nature, life as we do not know it, the multiverse. All those arguments, it just fails. So then what is the conclusion? The simplest explanation would be the universe was actually designed. Yeah, well, then of course the atheist and the skeptic will say, who designed the designer? Well, if you would have the ultimate explanation of something, the ultimate basis of existence does not have to have an explanation. Let's say the atheist is right and our universe, the Big Bang, came from some wider universe and there is eternal matter or eternal fields that generate it. So how do you explain that eternal matter? It's just there. How do you explain the eternal field? It's just there? Yeah, fine. Oh, but the designer, that's too complex. Yeah, but well, okay, that's debatable. Because in classical theology, God is actually very simple. In process theology, probably God is more of a complex entity, but so even if God would be complex, which is very disputable, the ultimate cause of something does not need to have an explanation. If you ask the atheist, yeah, what explanation does your eternal matter? It's just there. Yeah, well, God is also just there. So, discussion over. So now is the question, is this an intelligent design argument? Well, I would say no. So that's basically my last slide. Sorry, I'm a little bit over. So is this a God of the gaps? So the skeptic will always say, yeah, but you have now hidden God behind the Big Bang. Well, but the problem is, so the God of the gaps concept refers to things that science does not yet know. And we are talking about things that science cannot in principle know. We cannot in principle conquer the particle horizon. We cannot, science cannot logically say, okay, why these laws of nature, why not any other? That is a why question, and that is outside of science. The intelligent design arguments, the complexity of cell, the origin of life, how can it all, the first replicator, how did it all arise? Well, the problem is that this is very vulnerable because science progresses and science does not yet know, but we probably will know. Evolution explains complexity perfectly, and I am convinced that the origin of life will be explained in the very near future. Second, the God of the gaps concept refers to design within nature. However, we're talking here about design of nature. So it is very, very hard to say, okay, yeah, science has so far shown that physical and biological evolution, everything is self-sufficient. Nature is self-sufficient. Okay, we're going to hide God somewhere in the gaps, somewhere in between, what we cannot explain yet. We put God into nature, and we make him compete with the forces of nature. So he's just somebody else who just competes with nature. That's dangerous. However, the fine-tuning argument basically puts God above nature. God makes nature, and nature works self-sufficiently because God made it that way. So God is now not just one force that competes with other forces in nature, which actually makes him pretty small, but he's the originator of the nature. And that is in my view, much more powerful. So last is, I want to recommend some literature for those who are interested to read a little bit further. It's a really fascinating topic in my view. Martin Rees, Just 6 Numbers. Martin Rees is a famous British astrophysicist and agnostic, and he has just 6 numbers. He takes 6 of those physical constants and then argues why they are so improbable by chance. He's a proponent of the multiverse. And then Stephen Barr, Modern Physics and Ancient Faith. That book has really helped me a lot. Also in other terrains like the argument from reason why, for example, why the brain is not simply a glorified computer and everything. So he explains things very well. So I would recommend those 2 books. I can give you the web address to my article, but you know web addresses, URLs are very complicated. So why don't you simply Google cosmological arguments and my name, and you will find my article on this.